meandering winds. Okay, so that what we have discussed with regard to jet stream. The jet stream is okay, meandering wind. It moves in a snake-like pattern, or it is a Rossby wave. That is what we have discussed with regard to jet stream. And we covered the concept of mid-Julian oscillations also. We discussed how mid-Julian oscillations affect Indian monsoonal system. So when there is a mid-Julian oscillation over India, what India will receive more rainfall or India will receive less rainfall? When there is a mid-Julian oscillation over India, whether India will receive more rainfall or whether India will receive less rainfall? More rainfall, yes. Okay, so that we discussed how it affects Indian monsoon. Finally, we discussed concept of polar vortex, and we discussed this is a reason why, okay, that Donald Trump is saying that there is no climate change happening, and we discussed those particular issues also in the last class. So today will start with the concept of oceanography. So we are done with the two part, geomorphology and climatology. Now we'll start with oceanography part. So what is oceanography? The first thing, you have to study about oceans. All things what is there in the oceans, you have to study things related to the oceans in the oceanography part. So what things you have to study? The first thing, salinity of the oceans. Why the ocean water is saline in nature. Salinity of the oceans you need to study. Thermal temperature of the oceans you need to study, because both this salinity and thermal things determine what? They determines the movement of water. They determines the movement of water. So you have to study about the salinity. You have to study about thermal, that is thermal part of the oceans. You also have to study about what with the topic we have taken, oceanic bottom relief. What is oceanic bottom relief means? What is oceanic bottom relief? What is relief? What is relief? So we discuss reliefs are the highland or lowland features that you are finding. That is called as a relief. Relief is what? Highland or lowland feature. And bottom means what? So this, if this is the water, if this is the oceans, you find at the bottom of the ocean, what features, highland or lowland feature that you are finding at the bottom of the ocean, that is called as a oceanic bottom relief. So one thing that you have to study also is a oceanic bottom relief. The fourth thing that you have to study here is a concept of tides, how the high tides and how the low tides are being formed. That is going to be studied under the oceanography. Then movement of water. Water can move in three forms: oceanic current forms, wave forms, as we discussed, tide form. So water can move in different forms. So you have to study about movement of water in terms of oceanic current, oceanic wave, oceanic tides. You have to study about deposits in the ocean. What kind of deposits that you are going to find. So you know that when rivers comes and joins the sea, what happens? When rivers comes and joins the sea, what happens? Rivers contain what? River contains many sediments, because the river is eroding, so river contain many sediments. These sediments get down where? At the bottom of the ocean. So oceanic deposits you need to also study. That concept is there. And the lastly that you have to study is a concept of marginal sea. Marginal sea. Marginal sea concept, that is okay there. Clear? What is marginal sea? Sea that are found on the margins of the continent. Sea that are found on the margins of continent are called as a marginal sea. Like we discussed, this is okay, Africa, and this part is your Arabian region. So which sea lies over here? The Red Sea. So Red Sea is which kind of sea? It is a marginal sea because it is found at the margins of the continent. We discussed India, which sea, which you find over here, which region? Yeah, Gulf of Kutch. Okay, so you'll see Gulf of Kutch is which type of sea? Marginal sea. Clear? Even Bay of Bengal is which type of sea? Marginal sea, surrounded by the continent. So you will be studying about all these marginal sea. So these are the topics that is there in the case of oceanography. Fine. So you will be studying all things related to the ocean. What is oceanic salinity? What is thermal temperature of the oceans? Oceanic bottom relief, concept of tides, movement of water, oceanic deposit, as well as concept of marginal seas. So the first topic that we're going to take up today is what? Oceanic bottom relief. Fine. So as the introduction I've given, relief means what? The highland or lowland features that you are finding. The highland and lowland features you are finding at bottom of the oceans. The highland and lowland features that you are finding at the bottom of oceans is referred as what? Referred as a oceanic bottom relief. Now the question here is, why this highland and lowland features that you find? Because of volcanic eruption. Yes. Any other thing? Any other thing? Earthquake. Any other thing? Magma beneath the surface. So that is volcanic eruption only. Magma comes out in the form of volcanic eruption. Any other reason why do you see the formation of highland or lowland features? Yeah, tectonic movement. Plate moves. Tectonic movement is another region. Then any other feature? Just now we discussed rivers bring sediments and deposit where? In the ocean. So depositional feature. And the fourth is what? Fourth is there is a constant erosion also going on in the oceans. So erosional features. These four are the reasons, these four processes are the reasons why you see formation of highland and lowland things inside the oceans. Clear? So let's say this is the bottom of the oceans. Let's say magma comes out like this. Magma comes out like this, and if magma is spread like this, you're going to find what? You're going to find highland features inside the oceans. Fine? You're going to find this type of features inside the oceans. Second thing, let's say there is a plate. This plate is which plate? Oceanic plate. We discuss again another plate, which is okay, which plate? Oceanic plate. When oceanic collision happens, what happens? Yeah, we discuss denser oceanic plate will go down. So denser oceanic plate is going to go down. You remember Archimedes principle we talked about, always the less denser will float over what? More denser. So more denser material will go down. When more denser material will go down, what you're going to see? Formation of what? Trenches. Okay, so you see lowland feature, trenches are going to be formed. This is going to be formed. This is going to be filled with water. So you'll have water like this, and okay, you'll have more water going down in the form of nothing but trenches. So trenches are going to be formed. It is formed due to which type of activity? Tectonic activity. Let's say erosion happens. When erosion happens, what will happen? When erosion happens, what will happen? You'll find the mountain that has been created has reduced in height. The mountain that is created due to volcanic eruption has reduced in height. That is okay. Which type of feature? That is nothing but erosional features. That is okay there. Let's say rivers brings what? Rivers bring sediments. River are bringing sediments, and these sediments are coming in the ocean. So what will happen? These sediments will settle down at the bottom. So when these sediments will settle down at the bottom, what will happen? You'll see highland features are going to be formed due to depositional activity. Fine. So what you have to keep in mind is that why these bottom highland and lowland features are being formed inside the ocean are being formed due to these activities. That is volcanic eruption, tectonic movement, depositional feature, or erosional features. So if you have to define the oceanic bottom relief, how you'll define? How do you define the term oceanic bottom relief?
So it is highland and lowland feature of the oceanic bottom.
Created due to volcanic eruption, tectonic movement, depositional feature, and erosional feature. So the highland and lowland features you are finding inside the ocean created due to volcanic eruption, tectonic movement, depositional and erosional features are referred as what? Are referred as a oceanic bottom relief. These are referred as a oceanic bottom relief. Fine. So now we are coming up to see what are these oceanic bottom relief. So primarily we classify this relief into two parts. They are referred as a major relief, major oceanic bottom relief. You can write oceanic bottom relief, major oceanic bottom relief, and minor oceanic bottom relief. So they are classified into two parts: major oceanic bottom relief and minor oceanic bottom relief. Fine. So oceanic bottom relief, we categorize into two different parts. One is called as a major oceanic bottom relief, another we call it as a minor oceanic bottom relief. What is a major oceanic bottom relief? What is a major oceanic bottom relief? So major oceanic bottom relief are of four types. These are referred as a continental shelf, second that you find is continental rise, the third that you find is continental slope, and the fourth that you find is a deep sea plain. And this deep sea plain sometimes also is referred as abyssal plain. So these are the four major relief features which are called as a major oceanic bottom relief feature: continental shelf, continental rise, continental slope, and deep sea plain. This is also referred as which plain? Abyssal plain. This is also referred as which plain? Abyssal plain. Now, what are the minor oceanic bottom relief feature? There are a lot of things that is there. One is called as a ridges. Ridges are minor oceanic bottom relief feature. Second, we have already written trenches. Trenches are your minor oceanic bottom relief features. So ridges, trenches, there is something called seamount. We'll find Guyot, seamount, Guyot, referred as abyssal hills. You also have what? You also have the concept of atoll. That is another kind of minor oceanic bottom relief feature. Sometimes you also might see beaches. So you'll also see beaches which are which are nothing but minor oceanic bottom relief features. So these are these are nothing but minor oceanic bottom relief feature. So bottom relief features of oceans are classified into two categories. They are referred as a major oceanic bottom relief feature and minor oceanic bottom relief feature. Major is what? Continental shelf, rise, continental slope, and deep sea plain. And minor are what? Your ridges, trenches, seamount, Guyot, abyssal hills, and atoll. Fine. So the first we are going to discuss is major relief features. Then we'll come to the concept of minor relief features. Fine. Even one more thing you can write in minor relief feature is canyons, submarine canyons. You add that particular part also, submarine canyons. So one more minor relief features that you have is a submarine canyons. Fine. So this is another minor relief feature that you can mention. Fine. So this is your continent. This is land part, continent part. Continent. This is called as a continental shelf. Continental shelf. Continental slope. Continental slope. This part is referred as continental rise. Continental rise. Okay. From this part till this part, it is referred as deep sea plain. Deep sea plain or abyssal plain. Abyssal plain. Fine. This is referred as your trenches. Trenches. Fine. This is referred as your trenches. Then you also have what? You also have creation of various features like this or like this. Now this is called as your seamount. This is called as your guyot. Guyot. Then you'll also see like this, features like this. These are referred as ridges. These are referred as ridges. Fine. You also have another thing. Another thing. These are referred as your abyssal hills. Abyssal hills. Fine. Now you'll also see the features of, here you'll find something called like this. Like this. This is referred as a shoal. Shoal. Then you also have another features that you're going to find like this. You're going to find like this. Again, this is where water is there. This is referred as atoll. This is referred as atoll. Fine. So these are basically the features that you're finding inside the oceans. Continental shelf, continental slope, continental rise, trenches. Then you'll find seamount, guyot, abyssal hills, ridges, atoll, shoal. Fine. So the first thing we are going to take up is, okay, what is continental shelf? Clear? So continental shelf is nothing but, okay, what? It is nothing but seaward extension of the continent. Seaward extension of continent is seaward extension of continent. So this is continent, that is land part. Now when this land part is extending towards ocean, towards the sea, then it is going to be called as what? Then it is going to be called as a continental shelf. So continental shelf is what? It is a seaward extension of continent that you are finding. Fine. Fine. Now, why there is a seaward extension of the continent? Why there is a seaward extension of the continent? We are saying that when continents are extending into the oceans or towards the sea, you are calling this as a continental shelf region. Clear? Now, in this, the continental shelves are created because of three major regions. They are created because of three major reasons. What are the three major reasons? Either the continent, let's say this is a continent. Let's say we are taking up like this. Let's say this is a continent. This continent is going down. Okay, this is a water. And this continent is going down. When this continent is going down, what will happen? After a certain point of time, you see water will be moving ever what? above nothing but okay continent, because this continent is going down. Clear? So one major reason for creation is subsidence of continent. If land part is moving down, then what will happen? Water level will, let's say this was land, this was water. Clear? This is a land, this is a water. Now if land part moves down, what will happen? Water level will become up. Then water will enters into what? Water will enters into nothing but okay the continent part. So this is the reason why you see creation of okay continental shelf. Okay, so when land subside, you'll see what water level is okay up only. So this water level will enter to nothing but okay land side, and this will create what? This will create nothing but okay continental shelf region. So one reason is subsidence of continent. Second thing, nowadays we are seeing what? Climate change is happening. With climate change, what will happen? Yeah, water level is rising, so ice are melting. When ice will melt and water level will increase, continent is not going down, but water level itself is increasing. When water level itself increase, what will happen? They will enters into what? They will enters into the continent. So another reason why you see the formation of continental shelf is the rising water level. Rising water level due to melting of ice. Rising water level due to melting of ice, that can create nothing but okay what? That can create continental shelf. Fine. And the third major reason why it can be created is because sedimentary deposits are being brought by the rivers. Sedimentary deposits are being brought by the rivers. Let's say this is a continent. And this part is what? This part is nothing but okay your ocean part. This part is your ocean part. Now rivers are coming, and rivers are bringing lot of sediments with them. Now this sediments start getting deposited. When this sediments start getting deposited, what will happen? You see creation of what? Creation of continental shelf, because some part will be under the water and some part will be nothing but okay deposited. So sedimentary deposit that are being brought by the rivers, that can also create continental shelf. So continental shelf is created due to these three reasons. Subsidence of the continent, either continent is moving down, so water is entering, or water level itself is going up, that's why water is entering, or the third thing, rivers are bringing nothing but okay sedimentary deposit and depositing it. That is the reason why continental shelf is being created. So in simple term, what is continental shelf? It is a seaward extension of the continent that is there. Clear? Now if you see this point, from this point to this point, when continental shelves are there, you see the slopes are not very okay what? Slopes are not very steep. It is growing like okay going like this. It is not like this. Okay, so slopes is something that is gradual in nature. It is not very steep in nature. When you see continental slope, here you will see what? Slope is like this. But when you see continental shelf, you see nothing but okay slopes are something that are slightly gradual in nature. It is not very steep in nature. So continental shelf has what? Continental shelf has gradual slopes. The gradient is generally less than 1 degree. Okay, so not much of okay what? Not much of slope, steep slopes you will find. You will find gradual slope. Gradient is okay going to be less than what? Gradient is going to be less than 1 degree. That is okay there. Clear? Now, how much is going to be extension of this one? How much is going to be extension of continental shelf? On an average, generally you find this is around 70 to 80 kilometers wide. On an average, how much you see continental shelf? This area, this distance, how much can be there? This can be around 70 to 80 kilometer wide in nature. Clear? This is average length that you generally find with regard to continental shelf. This is not fixed. Some coastal areas may have, like, let's say this is a continental shelf. Some coast areas may have only 8 kilometer. Some coast areas may even have, okay, what may have even 1500 kilometers. Okay, this can be up to 1500 kilometer wide also. Clear? But an average 70 to 80 kilometers, what 70 to 80 kilometer is what you are finding the extension of continental shelf. Fine. Generally, wherever you see the mountains, near the coast. So we discussed, okay, this is what, this part is what, this part is North America. In the North America, which mountains you are finding over here? Rockies. And in the Southern America, which mountains you are finding? Andes. Okay, you are finding. So this mountain is Andes mountain, while this mountain is nothing but, okay, Rockies mountain. Okay, so wherever you are generally finding the mountain at, okay, what mountain at the coast region, there the continental shelves are generally absent also. It's not necessary that they are generally present. They may be absent at this region. Fine. So wherever mountains are being found at the coast, you'll see what, there you see continental shelf may be absent also. Clear? Continent will not be having seaward extension like this. Continent will have more of a gradual decline like this. Okay, they'll have more of a gradual decline. Why? Because mountains are there. Mountains will decline gradually. Okay, mountains will decline what? In the steep manner. They will not decline in a gradual manner. So that's why wherever mountains are present at the coast, you might see absence of nothing but, okay, continental shelf. Fine. And wherever continents are not there, mountains are not there at the continent, at this coast you will find very wide continental shelves. Very wide continental shelves. So the coast where you don't find what? Where you don't find mountain, you generally see wide continental shelf. The coast where you'll find mountains, you generally see what? You generally see absence of continental shelf. Clear? So you can see the variation. Continental shelf can be 1500 kilometer wide also. It can be, okay, small as 8 to 10 kilometer wide also. It can be absent also. It can be nothing but, okay, what? It can be very wide also. That is okay there. So you can see the variation in case of nothing but, okay, continental shelf. Fine. Now, since this continental shelf is closest to whom? Closest to nothing but, okay, the surface, what happens? Since this continental shelf is closest to the surface, sea level, it is closest to the sea level, what can happen? What can happen? The sunlight can easily penetrate to what? Sunlight can easily penetrate in a continental shelf region. Clear? Since it is closest to the surface, this region is closest to the surface, sunlight can easily penetrate in this particular region. So that's why continental shelf is very important. That's why continental shelf is very important. What is the importance of continental shelf that you are finding? So what is the importance of continental shelf that you are finding? One very important is that all producers of oceanic ecosystem are found in continental shelf region. Fine. All producer of oceanic ecosystem are found in which region? They are found in a continental shelf region. That is okay there. Clear? Fine. So why all producers? You know that producers requires what? Producer requires sunlight. Photosynthesis will only happen if there is a sunlight. Like on the land, how the food chain start? On the land, food chain start with the plants. From the plants, okay, what will happen? Herbivore, carnivore, okay, omnivore. That is how the food chain, okay, goes. So in the ocean also, algae and etc. requires what? Algae and etc. requires the sunlight. Okay, they can prepare their food only with the sunlight. And if algae will not be producing, then what will happen? You don't see fishes surviving, crabs surviving, other things surviving in the oceans. So what you see is all your, okay, what? All your producer of oceanic ecosystem are generally found in which region? Are generally found in a continental shelf region. Why? because sunlight can easily penetrate in this region. Photosynthesis process can easily start in this particular region. Clear? So that's why wherever more producers are there, what will happen? Wherever more producers are there, more food will be available. When more food will be available, what will happen? You'll find more of more of organisms also over there. So that's why this is a zone, extensive zone for fishing. It is extensive zone for fishing, zone of fishing or seafood, like seafood. Whatever seafood you are eating, from where you are deriving the seafood, you are deriving it from nothing but continental shelf region. So it is a zone of fishing. It is a zone of nothing but seafood. That is there. Clear? So whether prawns, crab, other thing that you are eating comes from where? Comes from nothing but this region only. So it is a very important food producing region also. Fine. The third importance of continental shelf region is, as we discussed, when rivers comes and joins the sea. When rivers comes and joins the sea, river will join which region? When rivers is coming like this and joining the sea, river will join which region? They will be joining the continental shelf region. So whatever the deposit that the rivers are bringing, they are depositing these deposit where? Whatever the rivers are bringing the deposit, they are depositing these in where? In the continental shelf region. Clear? Now you know that rivers erode. When rivers move, river erode things, that is there. So on the rivers, what you find? In the rivers, what you can find? You can find inorganic matters also. What is inorganic matter? Like clay, mud. When rivers are flowing, they will carry the sands, clay, mud. Inorganic things also you can find inside the river. You can find organic things also inside the river. What is organic thing? What is organic thing? Like you'll see, yes, rivers can what? Rivers can nothing but carry away dead bodies and etc. Also, river can carry away what? Carry away nothing but plants also, small plants also, they can erode and etc. That is there. Organisms, when they organisms which are surviving in river, when they die off, what will happen? Those deposit will come and it will be what? It will be nothing but over here. Rivers, when they move over rocks, what will happen? They will erode the rocks, and you know that rock contains what? Minerals. So river will also be carrying certain minerals also, that is there. Clear? So that's why continental shelf is a zone where you are finding what? You are finding lot of, it is a zone where you are finding lot of mineral deposits. You are finding lot of mineral deposit, as rivers are bringing these deposit and depositing this in continental shelf region. So you are finding lot of mineral deposit. Which type of minerals you can find? You can find copper, you can find iron, you can find even aluminum. So when rivers are flowing over rocks rich in copper, they will erode the copper. Rivers are moving over rocks rich in iron, they will erode such rocks. So all these rocks are going to be deposited where? All these minerals are going to be deposited, rocks are going to be deposited in a continental shelf region. Clear? So that's why we have used the term what? Earlier we have used this term polymetallic nodules. Polymetallic nodules. So the continental shelf contain lot of nothing but lot of polymetallic nodules. Poly means what? Many. We discussed polygon. Poly means many. Metallic means what? Metallic means many metals. When many metals are found, that is called as the polymetallic nodules. So continental shelf region contains lot of nothing but polymetallic nodules. You can find copper, you can find iron, you can find aluminum. All these things you can find from continental shelf region. Fine. Now, as we discussed, they contains what? They contains the organic deposits also. When organic deposits, like we discussed, they contains what? They contains the dead bodies of the dead bodies of the humans. Sometimes what? Animals. You'll also see nothing but what? Sea organisms or river organisms. So they contain these organic deposits also. Clear? When these organic deposits goes inside the ocean, what will happen? Goes inside the ocean, what will happen? Decomposition, degradation will happen, and as a result you'll see formation of whom? You'll see formation of the coal. You can see formation of whom? Oil formation. You can see formation of natural gas. So that's why they are also source of what? They are also source of oil. They are also source of gas. they are also source of oil, they are also source of gas. Okay, so this is something that you are also finding. This is something that you are also finding in a continental shelf region. So continental shelf region is also source of whom? Also source of oil, also source of nothing but okay, gas. Clear? Now when okay, what when nothing but okay, the when you are trying to explore things, when you are trying to explore things onto the land, when you are trying to find oil, gas onto the land, it is called as what? It is called as a onshore drilling. And when you are doing it on the ocean, it is called as what? Offshore drilling. Offshore drilling. Clear? So you have two concepts, onshore and offshore. When you are trying to extract oil from the land, it is called as what? Onshore. And when you are trying to extract it from the oceans or continental shelf region, it is called as which type of drilling? Offshore drilling. For example, if you are going through the news, one thing that you are constantly going to get is okay, what? KG basin. KG basin, drilling in KG basin. So can you name what is KG basin? What is KG basin? So if you are finding news, you can see KG basin, AP must have share in oil and natural gas resources. Okay, what is this KG basin? What is this KG basin that you are finding? It is a Krishna Godavari basin. Okay, it is which basin? KG basin stand for what? Krishna Godavari basin. From Andhra Pradesh, which river flows? Krishna river flows, Godavari river flows. So KG basin, that is why you are okay getting this particular region. Clear? Now you can see India Energy Week. Ken drives into deep water exploration with basin, KG basin. So again, what is KG basin over here? KG basin is okay, Krishna Godavari basin that you are getting. So where you are trying to explore, you are trying to explore. You know that this is how Godavari river flows. This is how Krishna river flows. Okay, that is okay there. So this basin, when you are trying to explore, for which region? Oil and gas, because we discussed river bring sedimentary deposit. So this river is depositing this oil, the sedimentary deposit, organic deposit. This is converted into oil and gas. So when you are trying to explore this particular region, this is okay what you are finding. Clear? Any doubt regarding this particular thing? So that's why constantly you are going to get this particular news. So why this particular news? Because continental shelf is also a source of whom? Continental shelf is also a source of oil and gas. Okay, because the river brings okay these deposits and deposit in the case of what? Deposit this in the case of the continental shelf region. Fine. Any doubt regarding this part? So these are okay what? These are the importance of okay continental shelf region. Okay, so it plays a very important role because all your oceanic system is driven by whom? All your oceanic ecosystem is driven by continental shelf region. Very rich ground for fishing, very rich ground for nothing but okay food and etc. That is okay there. A lot of minerals you can derive, and also you can derive nothing but okay lot of oil and gases from this region. That's why you see also another thing you can also get is, so you can see India is exploring this one. So you can see this news, okay, of press note detail regarding nothing but okay press information bureau. India advances deep sea mining. Why we are going underwater? We are going and trying to mines what? Trying to mines the minerals or metal that is okay there. India deep sea mining trial Varha 3 collects polymetallic nodules. So we are sending what? We are sending nothing but okay the machines inside nothing but okay oceans and trying to extract what? Which nodule? Trying to extract nothing but okay polymetallic nodules. Okay, so that's why you are finding a lot of these things okay with regard to polymetallic nodules. Fine. So this is how you see okay the things are going down and they are trying to extract nothing but okay what? They are trying to extract these nodules. Okay, so all these the small thing that you are finding is called as what? These are called as a polymetallic nodules. Okay, clear? So that's why continental shelf region is what? Continental shelf region is a source of okay, very high importance, because it can be used for what? It can be used for nothing but, okay, the production of or oceanic ecosystem sustenance. It can be used for fishing. It can be used for mineral deposit. It can be used for oil and gas deposit. Clear? It can also be used for generating wind energy. It can also be used for generating wind energy. That is, okay, another importance of continental shelf region. Yeah. Now, why wind energy on oceans? Okay, you are wanting to generate. Why wind energy on the oceans you are trying to generate? Okay, it's flowing there. Yes. Okay. What will happen when we discuss wind are flowing on the land? What is the problem? Disturbances, frictional force are there, buildings are there, that is obstructing. Okay, you see other are obstructing the flow of wind, but on the ocean there's no such obstruction. That is okay there. So wind can flow with much higher speed. That is okay there in the ocean. So that is one reason. Second reason is what? Second reason is what? Second reason is, when, let's say, for how you extract the wind energy, through the windmill. Okay, you install a windmill like this. No, this thing rotate and it generates what? It generates, okay, the energy. That is okay there. So you install a windmill. Okay, that is okay there. Clear? Now this is like a fan only. Like this is like a fan. When wind blows, okay, this rotate and this rotate. It generates energy through which you runs the turbines and etc. That is okay there. Clear? When fan rotates, what happens? When fan rotates, what happens? It makes certain noise. Like when it is not, okay, running, it is not making a noise. When you rotate it, what will happen? It will make a noise. That is okay there. So if large amount of, for extracting wind energy, what will happen? You have to install a large amount of windmill. And when large amount of windmill will rotate, what will happen? More sound it will create. When more sound it will create noise pollution. That's why you never see windmill being installed near what? Near the settlements. They are generally installed, okay, somewhere far off location. That is okay there. So that sound noise pollution is not going to be there. But at the oceans, since there is no population living, what will happen? What will happen? You don't have to worry about that. You can install the windmill over there, and okay, what will happen? It can generate nothing but, okay, what? It can generate the energy. So that's why it can also be helpful for, it can also be helpful for what? It can also be helpful for generation of wind energy. And lastly, we discuss which type of wind always blow. Which type of wind always blow? We discussed during daytime. During night time, what happens? During the daytime, the wind moves from where to where? From sea to the land. And during the night time, the wind blows from where to where? From the land to sea. Okay, so we call it as a sea breeze, and we call it as which type of breeze? Land breeze. So at the coast, you are always going to get a wind. Why you are always going to get a wind? Because during daytime, what will be happening? Sea breeze will come. During the night time, what wind will flow? Land breeze will flow. On the land, you may get a wind. Like right now, okay, you may see wind is blowing because of, okay, what? Because of, okay, outside weather. Tomorrow, if sunny weather are there, you may not see wind blowing. That is okay there on the land. So on the land, you see the wind may not be what? May not be always blowing. That is okay there. But on the coast, you'll always see wind blowing. Why it is blowing? Because there is always a land breeze, or there will always be a sea breeze. So that's why this can also be used for what? This can also be used for nothing but, okay, generation of wind energy. So that's why continental shelf plays a very important role. Fine. Now, how much is the depth of this continental shelf? How much is the depth of this continental shelf? It can vary. It can vary from 30 meters up to 600 meters. So maximum, okay, could be 600, minimum could be 30 meters. So from 30 meter to 600 meter is the depth. Clear? And what you see is, okay, the point where the continental shelf is ending, the point where continental shelf is ending, and what is starting? Continental slope is starting. So this point is where continental shelf is ending, and what is starting? Continental slope is starting. This point is referred as a shelf break. This point is referred as a shelf break, or ending point of a shelf. This point is referred as a shelf break or ending point of a shelf, where, okay, what? Where continental shelf will end and continental slope will begin. Fine. So this is all about concept of continental shelf. So what is continental shelf? It is a seaward extension of the continent. There are there are three major reasons why this continental shelf are being created. Subsidence of continent, rising water level, sedimentary deposit that are being brought by the rivers. As we discussed, extension could be what? Extension could be very wide also, like 1500 kilometers, or very small also, sometimes absent also, that is there. If mountains and etc. are being found on the coast, continental shelf will be absent, but in general, average is around 70 to 80 kilometer. How much is going to be depth? Depth could be 30 or depth could be maximum 600 meter, that is there. Clear? What is importance of these continental shelf? Importance is these are known for what? These are known for the food or fishing region. These are also known for minerals, also known for generation of energy, and all your oceanic ecosystem runs from this region. So this is the importance of continental shelf. Fine. The second we have is a continental slope. So second reason that we have is a continental slope. So as we discussed, continental slope starts from where? It starts from where? It starts from shelf break region. It starts from where? Starts from shelf break region. From where it starts? It starts from shelf break region. And you'll see the gradient is around 2 to 5 degree at this region, and the slope will be more steep in nature. Slope will be more steep in nature. Gradient will be around 2 to 5 degree, while the slope will be steep in nature in the case of continental slope region. So it starts from where? It starts from nothing but shelf break region, and what you see is gradient is around 2 to 5 degree. You'll find slopes are high, or slopes are steep in nature. Then you'll also find what? You'll also find the depth. Depth can be from 200 meters to 6,000 meter, means up to 6 kilometer it can be deep. From 200 meter to 6,000 meter, that is up to 6 kilometer, the deepness could be there. Clear? With regard to whom? With regard to continental slope. Fine. The continental slope marks the end of the continent. It marks the end of continent. It marks the end of continent. Clear? Clear? So if you see this particular part, what we have done, what we have written, it starts from which region? It starts from shelf break region, that is there. It could be from 200 meter to deep to how much meter deep? Up to nothing but 6 kilometer deep. That can be the extension of nothing but continental shelf. Then you'll also see what? Then you'll also see the gradient is very high. Here we discuss gradient is like this, slopes is gradual in nature, but here you see gradient is more like this. The end, and it marks the end of whom? It marks the end of the continent. Now what is starting from here? Oceans are something that are starting from here. So that's why this continental slope marks the end of whom? It marks the end of nothing but continent, and what start over here is from oceans. Start over from here. So that is what you have to keep in mind with regard to continental slope region. Clear? Since slope is very high over here, what will happen? Slope is very high over here, what will happen? None of the deposits is going to stick over here. The deposit will come down there. Let's say rivers brings the deposit. River brings the deposit. Let's say they start depositing sediments over here. Then what will happen? These sediments will not stick over here. They will come down under the influence of whom? Under the influence of gravity, because slopes is very steep in nature. That is there. That's why this leads to a lot of deposit. A lot of deposit moving downward towards nothing but what? Towards deep sea plain. That is there. Clear? So you don't see much of nothing but what? Much of nothing but deposits over here. But here you'll find two things. One is called as a canyons. So at this junction, you're going to find smaller one, which is called as a submarine canyons. Submarine canyons are found in this region. Submarine canyons are found in this region. Fine, that is okay, very important. Okay. And as we discussed, what other thing that you are finding, since it is marking the end of the continent, when continent ocean collision happens, what you're going to find? Trenches. Okay, so you'll also find presence of trenches in this region. Presence of trenches in this region. Fine. So remember, we discussed plate tectonics. We covered what? When continental plate collides with oceanic plate, what will happen? Continental plate is made up of which type of rock? Felsic rock. Oceanic is made up of which type of rock? Mafic rock. Mafic rocks means rich in iron, magnesium. Felsic rock means aluminum, silicon. Yes, okay, it is rich in this one. So we discussed in periodic table, you remember aluminum, silicon comes, okay, what? Earlier than what? Iron, magnesium. These are heavier thing. So heavier thing means what? The oceanic plate will subduct below whom? Oceanic plate will subduct below continental plate. So this is continental plate, this is oceanic plate. So what is formed over here? Trenches are being formed over here. Trenches are being formed over here. That's why in this figure, what we have written here is what? What we have written over here is trenches. Okay, so trenches are formed at this boundary where continent is ending and ocean. Since ocean plate is subducting below, okay, it is going down, you'll see formation of nothing but, okay, trenches like these. Clear? So generally you'll see trenches are how much deeper? Trenches are how much deeper? Generally trenches are around 3 to 5 kilometer deep. 3 to 5 kilometer deep from where? From sea level, from sea surface. From sea surface. So this is, okay, surface of the sea. From here, trenches could be how much deep? 3 to 5 kilometer deep that you are finding. Clear? So trenches are how much deep? Trenches are 3 to 5 kilometer deep. From which surface? From nothing but, okay, sea surface. Don't consider this sea level. Okay, not from sea level. We are talking about from which surface is 3 to 5 kilometer deep. From the oceanic surface or sea surface, it is 3 to 5 kilometer deep. Fine. The biggest trench we discuss is what? Mariana Trench. Okay, so biggest trench that we have discussed is Mariana Trench. So Mariana Trench is how much deep? 11 kilometer from the sea level. So from here to here, if you measure the trench height, it is 11 kilometer. That is okay there. So generally you'll find, okay, Pacific Ocean has a deepness of around 5 kilometer, and further 6 kilometer deeper is nothing but, okay, trenches. So Mariana Trenches is the deepest trench, which is, okay, what? Which is 11 kilometer in height. Okay, that is okay there. Clear?
On sea level. From sea level.
No. Mariana Trench we are measuring from the sea level. Okay, from the sea surface. From sea surface, they are generally how much deep? 3 to 5 kilometer deep. Clear? So let's say this is a Pacific Ocean. Pacific Ocean is how much deep? Pacific Ocean is around 5 kilometer deep. Then further 6 kilometer, okay, you see extension of Mariana Trench. Okay, that is okay there. So from sea level, their height can be how much? Around 11 kilometers. Fine. So this is something that you have to keep in mind. So trenches are something that are observed at the boundary. Why trenches are being observed at this boundary? Because of which type of collision? Because of oceanic continent collision. Whenever oceanic continent collision happens, we discuss oceanic plate are denser plate, heavier plate. As per Archimedes principle, they are going to go down because denser goes down, lighter remains up. Okay, that is okay there. So lighter remains up, denser goes down. This creates what? This creates something but, okay, trenches over here, and the trenches are generally 3 to 5 kilometer deep in nature. Fine. What is canyons? We discussed canyons. What was the canyon?
There are stone kind of.
Stone kind.
So there is no vegetation.
Yeah, the reason we discuss gorges and canyons. Okay, so gorges we discuss when rivers are flowing. When rivers are flowing, you'll find vegetation at the side. This vegetation, then it is called as what? It is called as a gorges. It is called as what? Gorges. When no vegetations are being found, rivers are flowing, then what will happen? It is called as a canyons. We discuss canyons are generally formed in what? Formed in the desert region that we have discussed. Canyons are generally formed in which region? They are generally formed in a desert region. That is okay there. Clear? But when these canyons are found inside the ocean, then it is going to be called as which type of canyons? submarine canyons. Okay, so when these canyons are found inside the ocean, then it is going to be referred as which type of canyon? Submarine canyon. So submarine canyon means what? Just now we discussed, okay, continental slope is like this. When continental slope is like this, what will happen? None of the vegetation will grow over here. Why none of the vegetation? Because nothing will stick, all will go down. So none of the vegetations you are going to find over here. So this is referred as what? This is referred as a submarine canyon. So submarine canyons means what? Low region like this with no vegetation on what? With no vegetation on the sides. Clear? So if you look at the figures of submarine canyons, so you are finding this region, this figure if you see. So this is what? This is a land part. We discussed land part. Then this region is continental shelf. Then sudden decline. This region is called as what? Continental slope. In the continental slope, you are seeing this region, no? The depth, okay, the region that you are seeing is, okay, what region that you are seeing is a low region like this. Okay, you are seeing this particular region, gap is there. This is called as what? This is called as a submarine canyons. Okay, so this is referred as a submarine canyons. Okay, so we discuss the water will be like this, water will move like this in this hole, and no vegetation on the side will be there. So this type of things are referred as what? This type of things are referred as a submarine canyons. Okay, clear? So in the continental slope region, what you're going to find in continental slope region, you're going to find presence of nothing but, okay, trenches, and you're going to find nothing but, okay, what? Submarine canyons. Okay, these are what you are finding in a continental slope region. Fine. Now just now you also see which region? Continental rise region. Now once, okay, what will happen? Once, okay, this slope is declining, when the slope is declining from here to here, you see continental slope. After that, before joining the deep sea plain, you see this region with a lower gradient. Okay, so this region with a lower gradient that you are seeing, this is referred as what? Continental rise. This is referred as which region? Continental rise region. So again, the slope has a very strict gradient, but when you are reaching to the bottom, then again what will happen? The rise is having what? Rise is having very gradual slope. Rise is not having very steep slope. Rise is having nothing but, okay, very gradual slopes. Fine. So what you find is, next feature that you find is continental rise. The next feature that you are finding is a continental rise. Continental rise. So what you see is it connects the continental slope with abyssal plain or deep sea plain. Continental slope with abyssal plain or deep sea plain. Second thing, what it does is gradient is again less than 1 degree, and slopes are gradual in nature. Slopes are gradual in nature, like continental shelf. So what does rise does? Rise connect what? Rise connect the slope with abyssal plain or deep sea plain, and what you are finding here is gradient is less than 1 degree. Slopes are gradual in nature, like what you are finding at the continental shelf. Yeah. Then this continental rise merges with whom? This continental rise merges with deep sea plain. It merges with the deep sea plain. Fine. So this is, okay, important thing that you have to keep in mind with regard to Fine. So what you are finding over here is so this region, from this region to this region is which region? Continental rise. It is connecting which two? It is connecting the continental slope with which region? With the deep sea plain region. And this is why we have written this region as which region? Continental rise region, that is okay there. So it connect and ultimately it merges with which plane? Ultimately it merges with the deep sea plane. Fine. So last feature that you find is a deep sea plane. Okay, last feature that you are finding is a deep sea plane. So what is deep sea plane? Now deep sea plane are, these are okay, the planes found at the oceanic bottom surface. These are the planes found at oceanic bottom surface. They are the flattest plane. They are the flattest plane and contain both type of deposit, terrigenous deposit and pelagic deposit. They contain both type of deposit. Clear? So they are flattest plane. They contain both type of deposit, that is terrigenous deposit or pelagic deposit. Clear? How much is going to be the depth? Depth is going to be varying between 3 to 6 kilometers. They are found at the depth of how much? They are found at the depth of around 3 to 6 kilometers. And they are covered with what? They are covered with the very fine sediments. They are covered with the very fine sediments. These fine sediments could be what? Clay, silt. Those sediments are something that are found at the bottom of the plains. Fine. Clear? So what is okay? We have written over here. If you see the diagram, so what we have written here is these plains. Okay, this abyssal plains are flattest plane. Flattest plane means what? There is no variation in height. There's no as such variation in the height. They are very flat like this. Okay, there's no variation as such in height. They are very flat like this. Okay, so you can see these are very flat like this. Okay, you are finding these are not having variation in height. They are flattest plane. Okay, that you are finding. And how much deep it is going to be there? This can vary from 3 to 6 kilometers. Okay, so we discussed this depth can vary from where to where? 3 to 6 kilometers. That is what you are finding. And it contains both type of deposit, terrigenous deposit and pelagic deposit. What is terrigenous and what is pelagic deposit? Now, let's say if any, you have heard about Titanic incident, no? Titanic sank. After sinking, where the Titanic went? At the bottom only, no? So at the bottom of the ocean, you will find many things, no? That is okay coming when Titanic is sinking. What is happening? Titanic is being found where? At the bottom of the ocean. That is okay there. Clear? Boats are being found at the bottom of the oceans. Let's say sea organism, when they die off, what will happen? Sea organism, fishes and etc. when they die off, what will happen? Okay, their bodies will be found, okay, or the things will be found at where? At the bottom of the ocean. That is okay there. So those deposit that originates from the ocean, let's say fishes die off, okay, algae die off, anything that dies off, like volcanic eruption is happening. When volcanic eruption happens, okay, what it will bring out? Ashes it brings out, dust it brings out. So those deposit that originate from the oceans, those deposit that originate from the oceans are referred as what? Are referred as your pelagic deposit. So what is pelagic deposit? These deposit originates from where? Originates from the oceans. This deposit originates from the oceans. So can be in the form of what? Can be in the form of, okay, the ashes, dust which is coming out in the form of volcanic eruption, or can be in the form of what? Can be in the form of, okay, skeleton, okay, other things, okay, that is coming from whom? coming from nothing but okay, organisms. Clear? So originate from the ocean can be in the form of organic and but goes into the oceans are referred as terrigenous deposit. Okay, so how from the land it moves into the oceans? Rivers. Okay, yes, rivers carries the sediments. Okay, you see, let's say, okay, what will happen? Cyclones happens. Okay, they destroyed water from the ocean comes into the land, and then it, okay, what, it withdraws it back. That is okay there. So when deposit from the land goes into the ocean, then such type of deposits are called as what? Such type of deposits are referred as a terrigenous deposit. Okay, so you have two kind of deposit in the oceans. One is called as a pelagic. Pelagic means these deposits originate in the ocean itself, not coming from the land. When deposit comes from the land and get into the ocean, then that such type of deposit are referred as a terrigenous deposits. Fine. So these are okay, what, these are nothing but okay, four major relief features that you are finding. Clear? So you are finding what? You are finding the continental shelf, continental slope, continental rise, and deep sea plain. That is okay there. So these are the four major relief features that you are finding. Any doubt regarding this one? Now, what are the minor relief features? So one minor relief features we have already discussed, which is canyons and trenches. Okay, these are the minor relief features already we have discussed. Canyons are formed where? In the continental slope region, and trenches are also formed where? In the continental slope region. Clear? Now, where do we see formation of what? Ridges. So what is ridges basically? This is okay, what? This is okay, ridges we have discussed. So ridges are nothing but okay, what? Ridges are nothing but your parallel mountain chain. Ridges are what? Ridges are basically your parallel mountain chain. So now we are coming to the ridges. What is ridges? Ridges are parallel mountain chain. Parallel mountain chain found inside the oceans. Found inside the oceans and formed due to divergence of the plates. Formed due to divergence of the plates. So ridges are nothing but okay, what? Ridges are nothing but okay, parallel mountain chain. So we discussed this is how water are there. This is how water are there. This is how you're gonna find okay the oceanic surface. When magma comes out and magma forms okay this type of chain, then it is going to be called as what? It is going to be called as a ridges. So volcanic eruption is happening. This volcanic eruption is creating which type of chain? Parallel mountain chain. Then this is called as what? This is called as a ridges. When ridges will be formed? When there will be divergence of the plate. Divergence of the plate means what? Let's say this is okay, what? This is one oceanic plate. This is another oceanic plate, and this is where waters are there. Okay, so this is oceanic plate, this is oceanic plate, this is water are there. When these plates were there, then what will happen? When these plates were there, they were not allowing magma to come out. Okay, these plates were there, they were not allowing magma to come out. When plate move away, then what will happen? Magma can easily come out. So this magma, which is earlier not able to come out because of the presence of the plate, when plate diverges, when plate move aside, so this oceanic plate moved this side, this oceanic plate has moved this side. When plate moves aside, the magma now can easily come out. The magma now can easily come out because space is there to come out, and this magma then will create what? Then create what we called as a ridges. Okay, so ridges are basically what? These are the parallel mountain chain. These are formed when plates are something that are diverging in nature. Clear? Any doubt regarding this particular thing? So next you also have something called seamount. Also have something called guyot. So when you see formation of mountain inside the ocean, when you see formation of mountain inside the ocean, this is referred as what? This is referred as a seamount. Seamount is nothing but okay, formation of whom? Formation of mountain inside the ocean. Seamount will have which type of summit? Pointed summit. Seamount will have which type of summit? Pointed summit. Okay, that is okay there. Clear? But let's say this is eroded like this. This seamount is eroded like this, and it now forms a flat summit. When it now forms a flat summit, then it is going to be called as which one? It is going to be called as a guyot. Okay, so when it becomes eroded and okay forms a flat summit, then it is going to be referred as what? It is going to be referred as a guyot. Okay, so these are mountains found inside ocean with pointed summit. Inside ocean with pointed summit. Pointed summit. Okay, right on. Mountains that have flat summit. Flat summit inside ocean. Inside ocean due to erosion of mountain. Due to erosion of mountain are referred as guyot. Are referred as guyot. Clear? So you have these two terms, seamount as well as nothing but okay guyot. What is seamount? Seamounts are, these are found inside the ocean with which summit? Pointed summit. When this okay is being eroded, flat summits are being formed, then it is referred as what? Referred as a guyot. Clear? All these features are referred as what? All these features are also referred as abyssal hills. They're also referred as which type of hills? Abyssal hills, because these are the hills created from the deep sea plains. Okay, these are the hills created from deep sea plain. So the seamount, guyot together is also referred as which hills? Abyssal hills. Okay, seamount, guyot, these are referred as which type of hills? These are referred as abyssal hills also. Fine. So that's why in this figure, that's why in this figure we have written pointed summit as what? Pointed summit as a seamount. So we have written pointed summit as what? Seamount. Flat summit as what? Guyot. When many hills, okay, we have shown it as what? Many hills we have shown at which type of hills? Abyssal hills. So guyot is also an abyssal hill. Seamount is also a abyssal hills. Okay, that is okay there. Clear? So these are the features, okay, that you are finding inside nothing but okay what? Inside nothing but okay the ocean in the minor form. So minor relief features are what? Minor relief features are your seamount, your guyot, your abyssal hills, your ridges, your trenches, your canyons. Okay, these are okay referred as a minor, okay, what? Minor the oceanic relief. So you may get a question like this. Which one? So seamount is formed due to volcanic eruption. Okay, but when erosion happens, then what will happen? Guyot start. Which statement is correct? One is correct. Second. Second one is also correct. Okay. Third is wrong. Fine. Anyone else? Third one is also correct. Fine. Anyone else? First and second. Third is correct. Third is wrong. Okay. Fine. So the first statement says continental shelf around east coast of India is wider than the west coast. So just now we discussed, okay, this part of India. Now which mountain you see over here? Western Ghat. Which generally you see over here? Eastern Ghat. Okay. So Western Ghat are, okay, more continuous mountain ranges, and we discuss whenever mountain ranges are going to be there, you'll see what? Continental shelf as a, when you see continental shelf either absent or very narrow in nature, that is okay there. When, okay, what will happen when you don't have a okay mountains, what will happen? You'll see continental shelf wider in nature. That's why east coast, okay, have a wider continental shelf. This is a wider continental shelf than the what? Than the west coast. Okay, so this statement is very correct, because at the west coast we have which mountain? Western Ghat mountain ranges, and this Western Ghat mountain ranges ensure that continental shelves are, okay, what? Continental shelf at the east coast, this side is wider than the west coast, this side it is not wider. Clear? This statement is also very much correct. Siberian Arctic continental shelf are what? Siberian Arctic continental shelves are widest in nature, around 1500 kilometers we discussed, okay, are found where? They are generally found in the Siberian region, Siberian continental shelf region. So you are finding that. And the third statement, continental shelf also contains submarine canyons. Is it correct? Wrong. Why? Which contains submarine canyons? Slope contains. Yes, continental slope contains submarine canyons. It is continental shelf that contains submarine canyons. Clear? So these type of questions, okay, you will get in the case of examination in the prelims part. Okay, so they may associate it with the, okay, continental shelf, continental slope, continental rise, deep sea plain. Okay, that is okay there. So those type of questions you will get in the case of examinations. Fine. Any doubt regarding this one? So remember that continental shelf is wider on the east coast of India rather than on the west coast of India. The widest continental shelf is found in Arctic Ocean. So Russia is extending into what? Russia is extending into Arctic Ocean or Siberian, okay, Arctic region. So what is Siberian Arctic region? So this is, okay, what? This is nothing but, okay, your Siberian Arctic region. Fine. So this part, okay, this part extending, okay, so this is Siberia region of Russia. This is extending towards which ocean? Arctic Ocean. Which ocean you are seeing over here? Arctic Ocean you are finding. So which oceans you are finding? Arctic Ocean you are finding. This is, okay, which region? Siberian region. So when Siberian region extend towards Arctic Ocean, this is called as a Siberian Arctic region. Here the continental shelf is what? Widest in nature. It is widest in nature around whole world. You'll see much of, okay, widening in this particular region. And lastly, we discuss continental shelves are found in which region? They are found in a slope region. They are not found in a shelf region. They start from shelf break, not from continental shelf. Okay, we discuss shelf break region where the continental shelf ends and continental slope starts. That is called as which region? Shelf break region. From shelf break you'll see, okay, origin of nothing but, okay, the submarine canyons. Fine. Fine. Any doubt regarding this one? So you will see Can you see this answer question? Comment on the resource potential of the long coastline of India. Comment on the resource potential of long coastline of India. Polymetallic nodules. You can write about what? Oil and gas. Geji basin. Just now we discussed Krishna Godavari basin. You can write about that. Then fishes. Then you can write about, okay, that this is a resource potential that you are finding. Then what else? Okay, you can write about. What else? Wind energy generation. You can also write about wind energy generation in this particular region. Then what else you can write about? What else? Okay, you can write about regarding resource potential. Solar energy. Can you write solar energy? Long coastline. India long coastline is falling in which region? Tropical region. Tropical region means what? More sunlight. So solar energy you can generate. So that is what, okay, you are seeing how the question has been asked in the case of examination. Identify the comment on the resource potential of long coastline of India and highlight the status of natural hazard preparedness in these areas. So we discussed cyclones. This, okay, because of coastline, India is facing a lot amount of cyclones, tropical cyclones. So how India is preparing with regard to tropical cyclone, that you have to write over here. Clear? So the first part we have discussed, comment on the resource potential of long coastline in India. So this question has been asked in 2023 paper. Fine. Yeah. Comment on the resource potential of long coastline in India. Fine. You can see why is India taking keen interest on the resources in Arctic region. Why is India taking keen interest in resources of Arctic region? We discussed Arctic region. What is there? Widest, okay, continental shelf. Okay, widest continental shelf means what? You can find more oil, more gas, more nothing but, okay, what? More nothing but, okay, even trade can possible, navigation can be possible over there. Then you'll also see, okay, more amount of what? More amount of deposit, fisheries, all those things. So that's why India has to take keen interest in, okay, what? Keen interest in case of Arctic region. So you have to associate this with what? You have to associate this with the continental shelf. That Arctic region contains wide amount of continental shelf, and continental shelves are rich in what? Continental shelves are rich in these things, okay, and that's why India is taking a keen interest in what? Keen interest in Arctic region. Fine. So you see, another question is saying, defining blue revolution, explain the problems and strategies of pisciculture development in India. So again, it is related with which one? Fisheries. Okay, it is related with the blue revolution. Blue revolution means what? What the term blue revolution means? It is not. It is all about oceans. From oceans, when you are deriving materials, resources from the oceans and using it for your own development, that is called as which type of revolution? Blue revolution. And pisciculture is all about what? Fisheries development. How fisheries development India can do, because you know that Tamil Nadu, okay, but Tamil Nadu fishermen, Sri Lankan fishermen, fight is going on, other things are going on. So how India can develop nothing but, okay, pisciculture in India. So remember the term blue revolution. Okay, remember the term blue revolution. So that is, okay, another type of questions you are getting from the examinations. Clear? Fine. So have a break and then we'll continue with further discussions on, okay, the oceanic bottom relief features. What is the difference between bank and shoal?
It's something which is near to the land.
Huh.
Like starting a
Hmm.
or shoal that is under the water.
No, shoal is okay elevation. It is elevation, land elevation that is coming from the water. From the water, it is a natural one. It is a natural one, and it is a detached elevation. We sometimes call it as a detached elevation. So it is a detached land or elevation which is coming out from the water. Let's say this is a water. From this, if okay, a detached land is coming. Let's say this is a land, and this part is detached from this particular part. So this detached land is okay. What this detached land is called as a shoal. Shoal is created due to nothing but okay natural process. Clear? On the other side, bank is okay. What bank is created due to deposition of sediments by the rivers. Sediments by river. They generally have a low elevations. They generally have a low elevations. So that's why bank allows navigation. Bank allows navigation while shoal doesn't allow navigation. Doesn't allow navigation. So bank and shoal. So it is okay. What it is? Bank is what? Bank is basically deposition. It is created due to deposition of sediments by the river, and this is generally low elevation. As a result, navigation is possible. While shoal doesn't allow navigation because it is a detached piece of land coming out from nothing but okay water, and that's why it doesn't allow the navigation part. For example, if you see the figure, now you can see this figure. This is what? This is nothing but okay a detached elevation of land away from what? Away from nothing but okay the land. This is a detached part, and when it is detached part, you can't move ship and etc. over here because water level is not there. When water level is not there, then what will happen? Navigation is something that is okay not possible. Clear? So that's why we are saying that it is high elevation that is coming from where? Coming from the water. It is created due to what? It is created due to natural process, natural reason, and that's why okay doesn't allow what? Doesn't allow nothing but okay navigation. The bank, okay, what bank is having? What bank having narrow elevation. They have narrow elevation, they can allow the navigation that is okay there. Clear? So these features you have when is which is called as a bank and shoal. So bank is what? Bank is formed due to deposition of sediments, and it is generally of what? Low height. When low height, then it allows the navigation, ship and etc. can move over it. The shoal is what? Shoal is nothing but okay detached elevation coming out from the water, and as a result, it doesn't allow what? It doesn't allow the navigations. Clear? So this difference you have to keep in mind. The third thing, the other thing we have written as a minor oceanic relief feature is atoll. Okay, the other thing that we have written as a minor oceanic relief feature is a atoll. What is atoll? So there is a something called coral reefs. There's a term called coral reefs. So atoll is a kind of what? Atoll is a kind of coral reefs. Okay, atolls are what? They're the kind of coral reefs. There are three types of atoll. There are three types of atoll. These are referred as a there are three types of coral reefs. One is called as a fringing reef. Another is called as a barrier reef. and the third is called as what? Third is called as nothing but okay, atoll reef. Okay, so there are three different kind of reefs, which is called as a fringing reef, barrier reef, and atoll reef. All these are which type of reef? All these are coral reefs. Fine. Fine. So what is coral reefs basically? What is coral reefs? So in the oceans, there is an organisms that is found which is called as a coral polyps. So in an ocean, there is an organism found called as a coral polyps. When this coral polyps exist in a symbiotic relationship, with whom? With algae, then this combination is referred as what? This combination is referred as a coral reefs. So what is coral reefs? Coral reefs are nothing but okay, when coral polyps, which is a organisms under the water, organisms under the sea, when coral polyps exist in a symbiotic relationship with whom? Symbiotic relationship with the algae. This combination is referred as what? This combination is referred as a coral reefs. What is symbiotic relationship means? We discussed, yes, both are benefiting each other. When both organisms are benefiting each other, then it is going to be called as which type of relationship? Symbiotic relationship. So on one side, coral polyps, what benefit they provide? They provide protection to the algae. They provide protection to the algae from nothing but okay, turbulence. They provide protection to the algae from turbulence. Water is moving, no? Oceanic currents are moving, waves are there, okay? There's a lot of there are a lot of movement of water. So from these turbulence, who provide protection to the algae? The coral polyps. On the other type, algae provide food to whom? To the coral polyps, okay, that is okay there. So algae are preparing their own food. They are the producer. They provide food to whom? They provide food to the coral polyps, okay, that is okay there. Clear? Now, coral polyps extract what we call as a calcium carbonate. They extract calcium from the what? They extract calcium from the water and build their skeleton. This hard skeleton, exoskeleton, is referred as what? Is referred as hard shell. Clear? So coral polyps extract what? Extract calcium from the water. They extract calcium from the water. Okay, what will happen is, okay, then they build what? From this calcium, they build calcium carbonate, and this calcium carbonate create their skeleton, hard skeleton or exoskeleton is there. Clear? On these skeletons, okay, who is okay kept? Algae are something that are attached to these skeletons. Algae are something that are attached to these skeletons, that is okay there. Clear? Any doubt regarding this particular thing? So why the calcium is present in case of water? Because calcium is present in the form of salt, calcium sulfate. You know that ocean contains what? Salt. Ocean water is what? Salty in nature. So they extract the calcium, the salt that is present in the ocean, and what will happen? They try to build what? They try to build calcium carbonate. That hard shell they try to build, hard skeleton they try to build. So when these hard skeleton, let's say this is okay, your water. So where the algae are going to be found? You know that algae are more going to be found in a continental shelf region. Why? Why? Because they are the producer. They require photosynthesis. So they are okay going to be found where? They are going to be found in a continental shelf region where sunlight can easily come. Okay, that is okay there. Clear? So when coral polyps and algae have an association near and hard skeleton are built near to what? Hard skeleton are built near to the coast. Then this type of reliefs are referred as what? Then this type of reliefs are referred as a fringing reef. Okay, when this type of reliefs are referred as a fringing relief. When they are building this hard skeleton away from the coast, then it is okay referred as which type of reef? Barrier reef. Okay, then it is referred as which type of reef? There is a barrier between coast and the hard skeleton. Then this is okay going to be called as a barrier reef. Okay, that is okay there. So if they are built near to the coast, it is going to be called as a fringing reef. And if they are being built away from the coast, then it is going to be called as what? They are going to be called as a barrier reef. Fine, any doubt? But what if they start building this okay reefs and okay this material starts to come above the water? This hard skeleton, hard thing starts to come above the water. What will happen? what will happen? Then they formed like this. This hard skeleton has come out. So here what is present? Water are present. And this hard skeleton has come out above the water, that is okay there. When it comes out, it is referred as a atoll. What it is referred as? It is referred as a atoll kind of nothing but okay reef. Okay, so there are three different kind of reefs, okay, that are there. One is called as a fringing reef, another is called as a barrier reef, and third is called as a atoll reef. If this hard skeletal formation happens, okay, what happens, okay, near to the coast, then it is called as a fringing reef. Away from the coast, then it is going to be called as a barrier reef. And this hard skeleton come above the water. If they come above the water, and if they come above the water, then it is going to be called as what? It is going to be called as a atoll reef. Fine. Fine.
So when about so they'll be in a vertical shape.
They'll be in a vertical shape. Yeah.
From the ground.
Yeah, yeah.
So don't they go with the water?
Don't they go? That's why they are hard, no? They are hard skeleton. They are not easily moved by
So they are
water.
attached to each other.
Which one?
Coral reefs.
Coral reefs are, we call it as a symbiotic relationship. Coral polyps are having hard skeleton. Let's say this is okay, coral polyps, an organism. This build this skeleton. Now further skeleton build, further skeleton build, further skeleton build, further skeleton build. What will happen? It will come above the water. So this skeleton is okay. What there, which is built by whom? Which is built by nothing but okay, coral reefs. Clear? And when this skeleton comes out, we call it as what? We call it as which type of reef? Atoll reef. And this is also referred as which type of island, because anything that comes out of the water, we call it as what? Island. So this is referred as which type of island? Coral island. Okay, so like we discussed, Andaman and Nicobar is which type of island? Volcanic island formed due to volcanic eruption. Lakshadweep is which type of island? Coral island. Lakshadweep is which type of island? Coral island. Which type of reefs are going to be found in Lakshadweep? Atoll reefs are going to be found. When this skeleton comes out, they forms okay what? They forms the hard area, and on this hard area you see nothing but okay, population can live, okay, humans can live, and this is okay where how Lakshadweep has formed. So Lakshadweep is which type of island? It is a coral island. Clear? So that's why you'll see this. If you see this figure, you can see Lakshadweep is an archipelago consisting of 36 islands, including how many atoll? 12 atoll. Okay, so atoll is what? Atoll is nothing but okay, the skeleton that is coming out of nothing but okay, what? Out of nothing but okay, the surface. So that you are finding with regard to nothing but okay, atoll. Fine. So this is how you see the things are coming out. So this is how you see material are something that are coming out, and this create what we call as a coral island. So you see this is coming out above the water, the skeleton is coming out above the water, and this is called as a which type of reef? Atoll reef. Okay, that is okay there. Clear? Now if you see coral, okay, what coral reefs inside the water? Now you can see this is okay, what? This is nothing but okay, coral reefs. These are okay, coral reefs, okay, that you are finding. You can see a lot of colors are there, no? Why these colors are there? You can see this particular okay, orange color. You can see different colors okay, that are present. This colors is due to presence of which one? Algae. Okay, because algae are attached onto the surface. Okay, that is okay there. We discussed okay, this hard skeleton provide protection to whom? protection to the algaes. So algaes are attached. Okay, so this colors comes from where? This colors comes from nothing but okay, algaes. That is okay there. Clear? Now when this symbiotic relationship break down, then what will happen? When this symbiotic relationship break down, coral polyps and algae are not together, then what will happen? Then there will be no colors to the coral, and this phenomena is referred as what? This phenomena is referred as a coral bleaching. This phenomena is referred as what? Coral bleaching. So when algae symbiotic relationship between coral polyps and algae break down, this phenomena is referred. This phenomena is referred as a coral bleaching. When you bleach, you lose colors, no? Okay, so that's why it is referred as what? It is referred as a coral bleaching phenomena. Means corals are losing color. Why they are losing the color? Because we discussed color is due to algae. If algae are not present, then they will lose the color, and this phenomena is referred as a coral bleaching phenomena. Fine. So you can see, I'll just show you also figure of coral bleach. Now you can see this is how the corals were there. Now this is how they are looking. So this phenomena is referred as what? This phenomena is referred as a coral bleaching phenomena. Coral losing their colors. This is okay, referred as a coral bleaching. Coral are devoid of any colors. Clear? Now if you see coral polyps, so these are your coral polyps organisms. Okay, these are your this is how the coral polyps looks like. Okay, so you can see they are okay, what having what? So you can see they are having lot amount of what? Lot amount of skeleton that is coming out, on which okay, which is attached, on which is attached algae are something that are being attached. Clear? So it is like this, no? You have like this, okay, like this surface. So you see a okay things, and around surrounding that, okay, you are seeing this type. So on this surface only what get attached? Corals get the algae get attached. Okay, that is okay there. So when algae are not there, this phenomena is referred as which phenomena? Coral bleaching phenomena. Clear? So that's why there are two type of island you have to keep in mind. One is volcanic island. We discussed when volcanic eruption happens, then if volcanic eruption comes out above the water, it forms which type of island? Volcanic island. Andaman and Nicobar is example of which type of island? Volcanic island. When okay, skeleton comes out and this hard skeleton are something that are being built, okay, then it is called as which type? Which type? It is called as a coral islands. Lakshadweep is an example of which type of island? Coral island. Fine. Now we are saying this. Just assume this one. We are saying this is a water. This is a water, and we are seeing this is how the corals are building their what? Corals are building their skeleton. So when skeleton comes out of nothing but okay, this water, then what will happen? You see, this part of water is now cut off from what? This part of the water is now cut off from the ocean. Okay, that is okay there, because it is surrounded by two atolls. Okay, that is okay there. Clear? So this part is going to be referred as what? Lagoons. Yes. Okay, remember lagoons? We discussed what is lagoons. It is a part of okay, body of water which is cut off from what? Cut off from the main water. Body of water that is cut off from main water is referred as what? Is referred as a lagoons. Okay, so that we have already discussed lagoon concept. So lagoon is what? It is a body of water that is cut off from the main water. So that's why Lakshadweep is known for what? Lakshadweep is known for lagoons. Okay, Lakshadweep is known for lagoons. We discuss another name for lagoons is what? Another name for lagoons is what? Remember in Kerala they are referred as? In Kerala they are referred as backwaters or kayals. Okay, we discuss in Kerala the lagoons are referred as what? Backwater. Okay, clear? So that's why you'll find So if you see this, it is written what? Flying over Kerala, backwater lagoons on one side. Okay, so what is backwater? Backwater is lagoons only. Clear? So that is what, okay, you are finding. So these all the water bodies, the part of the water which is cut off from the main water is referred as what? Referred as a lagoons. Okay, so that's why Kerala, you see Lakshadweep, these are famous for whom? These are famous for nothing but, okay, backwater or lagoons. Clear? So this is all about what? This is all about the concept of bank, shoal and reefs. Okay, so what is reef? What is reef? Not relief. What is reef?
Say by the relationship between algae and
Coral polyps. Yes. Okay. When there is a symbiotic relationship between algae and coral polyps, these are going to be referred as what? These are going to be referred as a reef. Reef can be of three types. What are the three types of reef? Fringing, barrier, and atoll. Clear? What is fringing reef? Near to the coast, which is okay, found away, is called as a barrier reef, and which is found what? Which is coming out of the water and containing what? Containing the lagoons, okay, is called as a atoll reef. Fine. So the best example of coral reefs or best example of reefs you're gonna find is so you can see this is Australia. Fine. What you are finding over here on the coast of Australia? What is written? Great Barrier Reefs are something that are written. So where do you find the coral reefs, okay, or barrier type of reefs? Best example of reefs are Great Barrier Reefs, which are found where? Which are found in the northeast part of northeast part of Australia. So just note down this example. Great Barrier Reef found in northeastern part of what? Found in northeastern part of Australia is the best example of coral reefs. Fine. Now the question here is why the symbiotic relationship will be there and why this symbiotic relationship breaks down. What is the reason why you see symbiotic relationship are there and why do you think symbiotic relationship breakdowns? Because when it breaks down, we call it as what? Coral bleaching. So why this symbiotic relationships are there and why this breaks down? So for reefs to form, certain conditions you need to keep in mind. Clear? For reefs to form, certain conditions need to be satisfied. Okay, if these conditions are not there, then what will happen? You will not see formation of coral reefs. So we discuss coral reefs requires what? Calciums. So coral polyps requires calcium, while algae require what? Sunlight. So generally, you'll see the reefs are found where? The reefs are generally found in a tropical or subtropical water. They are found where? They are found in tropical or subtropical water. As you move towards what? As you move towards temperate region or polar region, what will happen? Sunlight decreases. When sunlight decreases, what will happen? Algae will not be okay. What? Algae will not be okay getting in association with whom? In association with the coral polyps. Clear? So majority of coral reefs are found where? Majority of coral reefs are found in a tropical region or subtropical region, because more amount of sunlight is something that is okay present in this region. When more amount of sunlight will be present, what will happen? We'll see association will be formed. And as you are moving towards temperate region, that is towards okay coast of whom? Coast of okay the Britain, or you are moving coast of a Scandinavian nation like Norway, Sweden, or further polar region, you don't find okay much of coral reefs over there. Why? Because sunlight decreases. Second thing, they are generally going to be found in which type of water? Shallow water. Okay, they are going to be generally found in which type of water? Shallow water. Because if shallow water is there, then only sunlight can penetrate. If sunlight will not penetrate, then what will happen? So generally corals are not seen deeper. Okay, you don't find coral reefs are being seen at the deeper level. For symbiotic relationship to be found, they are generally found in which type of water? Shallow water. That's why we discussed they are going to be more found in which region? Continental shelf region, because shelf is where sunlight can penetrate. When you are moving towards slope or when you are moving to a deep sea plane, sunlight will not much penetrate. When sunlight will not much penetrate, you don't see formation of whom? Formation of coral reefs. Okay, so they are found generally in which type of water? Shallow water and tropical or subtropical water. Fine. The third important thing, we discussed coral polyps requires what? Calcium, while the algae requires what? Algae also requires fresh water to survive. Okay, so algae can't survive in saline water. Okay, but for coral polyps, what is required? Calcium is required. Calcium will come from which type of water? Saline water or the salty water only, that is okay there. That's why coral reef formation happens in which type of condition? Mild salinity condition. This mild salinity allows coral polyps to extract salt, but okay, it does not allow it also allows algae to survive in these conditions, because if too much saline conditions are there, algae will not be able to survive. Okay, so algae that's why always you'll see coral reef formation happens in the case of mild salinity conditions. Fine. Now, as we discussed, when coral polyps are building things, what they are building? Calcium carbonate. Okay, so for this, okay, what you require? Not only calcium, you also require which ion? Carbonate ion. Okay, so you also require calcium, you also require which type of ion? Carbonate ion. Clear? Now, if okay the oceanic water become acidic in nature, then what will happen? If water become acidic in nature, then what will happen? Water become acidic. You need, remember we discussed when with this carbonate ions, what they form? They form carbonic acid. So when carbonic acid is being formed, then what will happen? Water becomes what? Water becomes acidic in nature. When okay carbonic acid will be formed, carbonate ion is not available to form what? Carbonate ion is not available to form what? Calcium carbonate, because carbonate has been reacted with what? Reacted with the water. It is not reacting with calcium, it is reacting with the water. So the coral reef survives in which type of water? Non-acidic water. If water becomes acidic in nature, then what will happen? Then there will be no availability of whom? Carbonate ion to bind with the calcium, because carbonate ion has reacted with whom? Reacted with the water that is okay there. Clear? To form carbonic acid. So they survive in what? They survive in non-acidic water. They survive in which type of water? Non-acidic water. If water turns into acidic, then coral reefs are not going to survive. Clear? So that important thing you also have to keep in mind, that the coral reef survives in which type of condition? Non-acidic conditions, that is okay there. Clear? Now coral reefs requires a bit of what? A bit of colder temperature, not warmer temperature. Coral reefs requires a bit of which type of temperature? Colder temperature, not warmer temperature. If warmer temperature are they going to be there, then what will happen? If warmer temperature are going to be there, then what will happen? Clear? Remember, if water becomes warm, then what will happen? You see, warm water is what? Warm water is expansion happens. Warm water becomes less dense. Density is what? Mass by volume. So, okay, when anything is heated, what happens? It expands. So, volume expands. So, what will happen to density? Decreases. Density decreases. So, warm water is okay, what? Less denser in nature. While cold water is what? Cold water is what? More denser in nature. Cold water is what? More denser in nature. That is okay there. So always warm will remain up and cold will remain down. Turbulence is not there. Clear? Because if okay, cold water moves down, warm water comes up. If this things happens in the ocean, then what will happen? There's a turbulence, movement of water. If there is a warm water means it will always remain at the surface. It will not move down. Cold water will not come up. That is okay there. Turbulence is not there. When turbulence is not there, then what will happen? Do you think algae require protection at that point of time? No, algae does not require protection. Algae will require protection when there is more turbulence. Okay, when there is a lesser turbulence, algae will not require protection. That is okay there. Clear? So that's why which type of water generally you see colder water, colder temperature, because it leads to more more nothing but turbulence, movement of water. That is okay there. And if movement of water is going to be more, then what will happen? Then algae will come in association with whom? Algae will come in association with the coral polyps. Okay, so that's why when temperature increases or global warming, we are saying global warming is happening or oceanic temperature is increasing, it is also destroying which type of association? It is also destroying the coral reef association, because warming of water means what? It will destroy the coral reefs phenomena. Yes.
So the colder water will have turbulence.
Colder water if is there, colder water is what? More dense. More dense means what? It will starts to go down. Clear? Warmer water will come up. So movement of water is there. No? When movement of water is going to be there, then what will happen? Turbulence. Algae requires nothing but what? Protection in that. Clear? So that is what you are seeing. So coral reefs requires a bit of which type of temperature? A bit of nothing but colder water. Not too much cold. Okay, only a bit of cold water. Okay, you'll require. Not too much cold water. That is okay there. Clear? Fine. Like in polar region, we have too much cold water. But in polar region, what will happen? Sunlight is not reaching. So when sunlight is not reaching, what will happen? Algae will not be seen over there. So a bit of colder water is required. Not too much colder water. Fine. Any doubt? So mild salinity, mild cold water. Okay, you will find what? Non-acidic water, shallow water, tropical and tropical water. In these regions, what will happen? In these regions, coral reefs association will be formed. Coral reefs are going to be formed in these association. Another important conditions could be what? Another important condition is transparency. Transparency of water. If water is transparent, then what will happen? If water is transparent, more sunlight will go down. When more sunlight go down, what will happen? More more association will be formed. If transparency is not there, then what will happen? Less water. So when transparency is not going to be there, when transparency is not going to be there, when lot of pollutant, when lot of pollutant entering into what? Entering into the oceans. When a lot of pollutant entering in the oceans, then you will find what? Then you will find nothing but lot of lot of nothing but problems. So transparency of water is something that is required. So any change in these will cause what? Will cause disturbance and coral bleaching to occur. Any changes in this will cause disturbance and coral bleaching to occur. Fine. Which is a correct statement? Second is correct. Okay. Anyone else? Both are wrong. Anyone else? Both are wrong. So first statement says coral reefs, coral bleaching occurs due to anthropogenic phenomena only. Correct or wrong? Wrong. It can happen due to natural phenomena also. If warming of temperature happens due to what? Anthropogenic means human related phenomena. Clear? So it can happen, okay, due to natural phenomena also, like El Nino condition. Remember El Nino? We discussed warming of, okay, what? When Peru current, which is okay, warm, colder current becomes a warmer current, then what will happen? What will happen? You'll see temperature increase. When temperature increase, what will happen? Bleaching will occur. Clear? So it can happen due to natural causes also. It can happen due to human causes also. First is wrong. Second, coral bleaching occurs when coral polyps loses their color. When coral polyps loses their color. Is it correct? It is wrong. Coral polyps do not have a color. We discussed why they get the color. Because of algae. Okay, so okay, coral bleaching occurs or coral bleaching occurs when algae get detached from what? Coral polyps, and because of which coral polyps do not get any colors. Okay, that is okay there. So that is wrong. So both statement are something that are wrong statement. Like this, you can get a question in the case of examinations. Fine. So have you gone through the speech of Prime Minister, Independence Day speech? Anyone has gone through Independence Day speech of the Prime Minister? No one. Huh? But you have gone home, no? Huh? Fine. Okay, go through that speech. Okay, just you will find some announcement has been done, important for UPSC. Just go through that.
So for UPSC,
Hmm. Hmm. What is it for UPSC means?
no,
Hmm. Hmm.
what announcement?
A lot of things like GST announcement has been done. Okay, defense related like the concept of Sudarshan Chakra has been done. Okay, so a lot of announcement recently has been done by the Prime Minister in Independence Day speech. Just go through that. Okay, it's important. 87, huh? March past. That is Republic Day. No? That's when Republic Day is what? What is Republic Day? What is term Republic means? It is over now. What is so what is Republic means? In the preamble you have the term, no? The socialist, secular, democratic, republic, those terms are there. Republic means what? That the head of the state is going to be elected one. Okay, republic means what? The head of the state is elected one, that is called as a republic. Who is the head of the state? President. So president is elected in India. Clear? So India is which type of country? Republican country. UK is not a republican country. Why? Because their king system is there. Head of the state is what? King and queen. Okay, that is okay there. So that is okay. Non-republican country. Though both are democratic country. So India is also democracy. UK is also democracy. But India has a republican system. UK do not have a republican system. So in India, the president is considered as a supreme commander of all the forces because he is the head of the state. So he is the head of what? Is the head of all three forces: army, navy, air force. Okay, he is the head of that. So that's why, okay, when Republic Day is there, we have this, okay, celebrations of marching and other thing, which is not there in the Independence Day, because Independence Day we are celebrating what? We are getting free from which one? Colonial rule, British rule. So, okay, we are coming up with nothing but, okay, this one. So we're not celebrating the Republican system over here. We are celebrating our independence, freedom. That is okay by us. Answer 87. I'll just zoom it itself. First and second are correct. Okay. Anyone else?
So animal fibers, animal types.
Coral reefs host far more number of animal phyla than those hosted by tropical rainforests. Yeah, it is a type of type only. You have phylum chordata, no? That thing is there. So phyla is there. Here all three statements are correct. Yeah. So most of the world coral reefs, just now we discussed why they are found. We have written tropical or subtropical waters. So that's why first statement is correct. Most of the one third of the coral reefs, just now we discussed, best example is Great Barrier Reef, Australia. So Australia, Indonesia, Philippines. These are the tropical region. You'll see a lot of nothing but coral reefs in this region. Even third is also there. Coral reefs are considered as one of the most productive regions of the world. Okay, these are referred as one of the most productive regions of the world. So they contain a lot of nothing but animal phyla. They contain a lot of animal phyla. So here answer will be what? Answer will be all three statements are correct. Answer will be D, 1, 2, 3. Okay, so like this questions can be asked in the case of examination related to coral reefs or coral bleaching phenomena. That is okay there. Clear? Any doubt regarding this particular thing? So there is also in environment you will read in detail regarding coral reefs. Okay, that is because it is a topic of environment also, coral reefs. But since we are touching at all reef, I have explained what is coral reefs, what is nothing but what is a condition in which coral reefs are going to be found, when coral bleaching will happen. Okay, so all these conditions, when it is not going to be there, then what will happen? So we discussed, okay, the transparency of water, if it is being affected or other things are being impacted, then what will happen? Then in such situation, you are going to see phenomena of what? In such situation, you are going to see phenomena of coral bleaching. Fine. So this finishes your concept of major and minor oceanic relief. Okay, this finishes your phenomena of major and minor oceanic relief. Oceanic bottom relief, we are done with this particular phenomenon. Clear? The second topic that we are taking up is the concept of oceanic salinity. So the second phenomenon we are taking up is concept of oceanic salinity. Now, what is oceanic salinity? So it is defined as amount of salt in gram dissolved in 1 kg of seawater. this is how we define the term salinity. Okay, so amount of salt in gram dissolved in case of 1 kg of sea water, this is referred as what? This is referred as a salinity. Clear? Any doubt regarding this one? So when we are taking oceanic water, when we are taking oceanic water over here, then what will happen? It is going to be called as which type of salinity? Oceanic salinity. Clear? Any doubt regarding this one? So amount of salt in gram dissolved in 1 kg of seawater, this is going to be called as what? This is going to be called as a oceanic salinity. Fine. Now it is expressed like this. It is expressed by these symbols. Okay, so this is how we express oceanic salinity. Let's say 27 parts per thousand. Okay, so this indicate how much gram is dissolved in 1 kg of nothing but okay water. This is how we indicate what? We indicate the oceanic salinity. So this is a symbol for whom? This is a symbol for denoting the oceanic salinity. Fine. Any doubt regarding this particular thing? Now the oceanic salinity, the ocean's salinity, why you need to study? What is the reason why you need to study?
So one, because many of the organisms in the ocean, it depends also on the salinity. Many cannot survive in more saline nature and many do survive in
more saline nature. Okay. Any other thing? Any other thing? Why do you need to study the salinity?
So second is coral reef.
Coral reefs. Okay. Then
It also contributes to rainfall.
It also contributes to rainfall. Yes. Okay. Kind of. Then, so as we discussed, salinity, when salt are present in water, then what will happen? Then salty water are more denser than fresh water. Okay, salt water is more denser than which type of water? Fresh water, which contain less amount of salt. Okay, now density means what will happen to volume? If it is more denser, what will happen to volume? Compressibility will be there. So salinity determines whether water is compressible in nature, compressibility is there, or expansion of the water is going to happen. So this is okay, something that is going to be determined. Clear? Now let's say if higher salinity is there, then what will happen to water? This water is having higher salinity. What will happen to with this water? This will starts to go down. Why it will starts to go down? Because it is more denser. We discuss higher saline water, salty water is what? Salty water is more denser. So the ocean salinity of ocean also determines movement of water. It also determines what? Movement of water. So it determines the compressibility or expansion of water. Compressibility or expansion of water. It also determines what? Movement of water. Clear? Third thing, it also affects your oceanic currents. It also affects your oceanic current. Oceanic currents are what? Movement of water from one location to another location. So it also going to impact your what? It also going to impact your oceanic currents. Fine. Fine. Of course, we discuss salinity determines your what? Coral reef formation. Salinity determines your what? Evaporation. Salinity also determines evaporation. Remember evaporation classes? We discussed, okay, which water will more evaporated, fresh water or saline water? Saline water. We discuss evaporation is inversely proportional to salinity. Evaporation is inversely proportional to salinity. If saline water are there, then what will happen? Less evaporation. If fresh water are there, then what will happen? More evaporation. But remember, we discussed at the ocean you have, okay, what? You have more moisture in the wind. Why at the ocean you have more moisture at the wind? Because generally at the ocean, what will happen? We discuss, okay, saline water are there. Ocean contains which type of water? Saline water. So evaporation should be less over there. So why we discuss more moisture in the wind? Yeah, due to the large amount of water that is present. So even if slight evaporation happens, wind contain nothing but okay, what? More moisture. Rivers and etc. contains what? Lesser moisture. Rivers and etc. contains okay, what? Contains lesser water, and as a result, lesser moisture in the wind. That is okay there. Clear? So salinity evaporation is inversely proportional to whom? Inversely proportional to the salinity. So it determines your evaporation. When evaporation is determined, what will happen? Rainfall or precipitation, because moisture in the air determines your what? Moisture in the air determines your rainfall or precipitation. Clear? If more moisture in the air, more evaporation means what? More moisture in the air. More moisture in the air means what? more rainfall, more precipitation will happen. Less moisture in the air means what? Less rainfall and less precipitation. So it also impact what? It also impact your global weather circulations. It also impact your global weather circulation as it determines your rainfall, precipitation and other thing that is okay there. Clear? So that's why it's important to study, okay, what? It's important to study the oceanic salinity. It's important to study the oceanic salinity. Fine? That, yeah.
When it compared to freshwater lakes and the oceans where the rainfall is more.
Fresh water and lakes where the
Freshwater lakes and the oceans compared to these two where
see depends upon location also. When we are talking about what? When we are talking about lakes present in what? Polar region, or lakes present in what? Lakes present in temperate region, they'll have lesser rainfall than the oceans. Okay, that is okay there. Clear? So depends upon location also. No, we discussed, okay, where you will have, remember lakes concept, we discussed lakes helps in what? Importance of lake help in moderation of climate. Remember, we discussed lakes helps in moderation of climate. We discussed Bangalore earlier at what? Many lakes. So many lakes means what? It used to have lesser temperature, but now lakes are not there. When lakes are not there, what will happen? More heat is there in the Bangalore now. That is okay there. So lakes helps in moderation of climate. Why moderation of climate? Because cooler wind moves from where to where? From lakes towards the land. Okay, that is okay there. So it minimizes the heat. That is okay there. Clear? But lake will have lesser amount of evaporation. Lake to have a lesser amount of evaporation. Lesser moisture content is going to be there in the air as compared to the oceans. Fine.
So previously you said that though the lakes are big small compared to the ocean, the evaporation and the rainfall in the lake is to be more compared to the ocean.
No, what I discuss is what we discuss. We have, okay, what we have a monsoonal wind coming from where to where? From the ocean to the land. Okay, so we discuss when wind are onshore in nature, then moisture contained, then we'll have, okay, more rainfall, otherwise lesser rainfall. We discuss land, okay, what there is more moisture present where? More moisture is present over the ocean than as compared to what? Land. Because why? Oceans are bigger in nature as compared to what? As compared to the lakes or as compared to the rivers. Okay, so when wind are getting moisture from this much area, and when wind are getting moisture from this area, which is a lake area, obviously even if more evaporation here happens, what will happen? Less moisture is going to be there. Here what will happen? More moisture are going to be there. Clear? But for rainfall to occur, what is required? What rainfall to occur, what is required? Remember types of rainfall. We discussed convectional rainfall, okay, orographic rainfall, frontal rainfall. So what will happen? Okay, when all these conditions are going to create, then only what will happen? Rainfall is going to happen. So if this condition, even if, okay, you have more moisture, if no mountain barriers are there, then what will happen? No orographic rainfall. When wind comes, okay, getting blocked by mountain, wind rise up. When wind rise up, cools down, it creates nothing but, okay, what? It create the rainfall in this particular region. So you have to have conditions being created, no, for the rainfall to occur. Either convectional condition, more heating need to be there. So on the land, if more heats are going to be there, then what will happen? Near the lakes, you see more rainfall because land is heated more. When land is heated more, what will happen? Air will be heated more because anything in contact with the hot surface, what will happen? It will get heated. Okay, so air in contact with the hot land, air get heated, air will rise up. When air will rise up, what will happen? Cooling will happen, cloud will be formed, and we'll see rainfall is going to happen. So depends upon the conditions. Okay, when we were discussing about conditions around the lake, then we have said that, okay, more rainfall in this area. Clear? Any doubt regarding this particular part? So why we need to study the salinity? We need to study the salinity because it determines what? Compressibility. It determines the expansion, movement of water, oceanic current. We have discussed, it determines evaporation, rainfall, precipitation. This is the reason why we need to study about what? We need to study about the salinity part. Fine. So if you see, Can you answer? You can see this question accounts for variation in what? Oceanic salinity and discuss its multi-dimensional effect. Clear? So this question has been asked in which paper? 2017 paper. Accounts for variation in oceanic salinity. So which oceans have more saline? Whether Pacific Ocean is more saline or Atlantic Ocean is more saline. Which ocean is something that is okay more saline? So variation in oceanic salinity and discuss its multi-dimensional effect. What is multi-dimensional effect? What are the multi-dimensional effect? So just now we discussed, okay, what ocean, okay, it is doing, what it is doing, it is determining your what? Evaporation. It is determining your what? Rainfall. It is determining your what? Precipitation. It is determining your what? Compressibility, movement of what? Oceanic current. So this is okay, multi-dimensional effect of whom? Multi-dimensional effect of oceanic salinity. Clear? So you can see directly the question has been asked related to oceanic salinity in the case of examinations. Clear? So you have to, what the question is asking is how variation of salinity is happening between Indian Ocean, Atlantic Ocean, as well as Pacific Ocean, and what are okay, what are nothing but okay effect of salinity. Why you need to study salinity? Why you need to know about salinity? That is okay there. Clear? So multi-dimensional effect of salinity. Clear?
Explain about all the oceans.
Yeah, you have to explain about all the oceans because okay, it talks about different. The question itself talks about different oceans. Okay, account for variation salinity of different oceans. So you have to talk about Pacific Ocean, Indian Oceans. You have to talk about okay the Atlantic Ocean, different oceans you have to talk about. Fine. Any doubt? So that is why you have to keep this in mind. Multi-dimensional effect, that is okay there. Clear? Now in prelims, you'll also see a questions. Okay, salinity questions has been also asked in prelims. So there the question has been asked related to what? Related to nothing but okay, the Red Sea. Whether Red Sea will have high salinity or Red Sea will have low salinity. High salinity. Why do you think Red Sea will have high salinity? Why Red Sea will have high salinity? So one reason that you see is okay, why salinity occurs? Why salinity will occurs? Evaporation need to be greater than who? Precipitation. If any area where evaporation is greater than the rainfall, because rainfall will add which type of water? Fresh water. Rainwater is which type of water? Fresh water. So if fresh water is getting added into the water, then what will happen? Salt content will decline. If more evaporation is happening, so we discuss water get evaporated, what is left behind? Salt are left behind. So when more evaporation is going to happen, then what will happen? You'll see salty conditions. Clear? So where do you find Red Sea? Where do you find Red Sea? In Africa region near Tropic of Cancer and Tropic of Capricorn. Okay, so there you'll find Red Sea, and Red Sea is okay being seen in those regions where rainfall is lesser. Red Sea is being seen in those regions where rainfall is something that is okay lesser. As a result, you'll see what? You'll see question has been asked regarding nothing but okay Red Sea in the examination regarding salinity. 89 you see the Red Sea received very little precipitation in any form. No water enters the Red Sea from the river. Okay, so here what you see is, okay, as we discussed, where do we find Red Sea? So this is, okay, what? This is nothing but, okay, Africa region, and we discussed this is Arabian region. This sea is referred as which sea? Red Sea. This sea lies where? This sea lies in which zone? Subtropical high pressure belt zone, and we discussed whenever high pressure zones are there, less rainfall is going to be there. And if you remember, we discussed which is the major river in African continent? Nile River. Nile River joins which sea? Mediterranean Sea. Okay, which sea? The Red Sea. So no major water. How the sea will have a water? How will sea will have a water? Either through fresh water, either through rain, or through river addition. River will go and add the fresh water. There are two ways fresh water can be added in the case of what? In the case of ocean. How the two ways? One is rainfall, another is river going and adding the fresh water. If neither things are, okay, happening in the case of Red Sea, because no rainfall as it is a high pressure zone, and no rivers is also going and joining the Red Sea, what will happen? Red Sea will have, okay, what? High salinity, that is, okay, there. Clear? So this is how the question has been asked related to salinity in both prelims and the mains examination. Clear? So remember, the Red Sea receives very little amount of precipitation in any form, and no water enters into the Red Sea from the rivers. As a result, what will happen? Both statements are something that are correct in the case of examinations. Fine. So what you have to keep in mind is what conditions determine salinity. Condition determining salinity. The first condition is what? Evaporation. The second condition is precipitation or rainfall. Precipitation or rainfall. The third condition is what? Addition of fresh water by rivers. Addition of fresh water by river. Fourth is what? Melting of ice from polar region, polar ice caps, glaciers. Melting of ice from polar ice cap region and glacier region. This can add what? This can add the fresh water. And the lastly that you have is what? Tide water glaciers. Tide water glaciers. Remember tide water glaciers? Three type of glacier we have discussed: Piedmont glacier, the tide water glacier, and alpine glacier. So glacier that comes and joins the water is referred as what? Water is referred as a tide water glacier. So glacier will add which type of water? Fresh water. Lastly, you have which what? Oceanic current. Lastly, you can have which affects the salinity. Oceanic current can impact salinity. So these are the factors which determines your salinity. So we discussed for salinity to occur, what is required? Evaporation need to be greater than what? Evaporation need to be greater than precipitation. This condition need to be there. The second condition is what? No addition of fresh water by these method. No addition of fresh water should happen. And the third is oceanic current. Okay, sometimes, okay, you see oceanic current can, okay, what? Oceanic current can add, okay, water. Like if you see, this is Africa. Here you'll find what? Here you'll find Southern America. Here you'll find what? Northern America. Now here you see movement of water like this. Clear? So this stream is referred as what? This stream is called as a Gulf Stream. Okay, this stream is referred as a Gulf Stream. This Gulf Stream take, okay, water towards where? Towards the coast of Britain. It takes water towards coast of whom? Coast of nothing but, okay, Britain, that is, okay, there. Now which region is this one? As we discussed, high pressure belt region. High pressure belt region means what? Water is going to be saline in nature, because evaporation is what? Evaporation is more, precipitation is less. High pressure region we already discussed, no rainfall is going to be there. So saline water will move from here to here. That's why coast of the Britain, here you will find a sea called as a North Sea. North Sea have a higher saline water. They have a higher saline water because saline water is moving from here to here. Clear? So that's why North Sea generally have a higher saline water. So even oceanic current can determine what? can determine the salinity. If saline water is moving from one region to another region, that is okay there. Clear? So these factors you keep in mind, that these are the factors which are affecting your oceanic salinity. Clear? Evaporation, precipitation, addition of fresh water, melting of ice, tide water, glacier, as well as nothing but okay, oceanic current. Fine. So how do we define the term salinity? How do amount of salt dissolved in 1 kg of sea water, and as we discussed, symbol of salinity is what? Symbol of salinity is this is okay, symbol of salinity. That is how we indicate the salinity part. And one more thing we discussed, when water will be called as a fresh water, when it will be called as a brackish water, when it will be called as a saline water. So we discussed if it is less than what? 5 parts per thousand. If salt water is salt content is less than 5 parts per thousand, then it is going to be which type of water? Fresh water. We discussed 5 to 35. Then it is going to be which type of water? Brackish water. Greater than 35, then it is going to be which type of water? Salt water. Okay, so salinity salt water is when salinity content should be greater than 35, then it is going to be called as a saline water or a salt water. Fine. Any doubt regarding this one? So fresh water, brackish water, and saline water. Clear? So generally you see salinity of open oceans. Salinity of open ocean like Pacific Ocean, Indian Ocean, and as well as we discuss Atlantic Ocean, they generally varies between this range. If it is an open ocean means what? Open ocean is there is free flow of water movement and etc. Clear? But this is okay, normal variation. Open ocean normal variation is 33 to 37. But at places you will find more salinity, at places you will find lesser salinity. This is average, general concentration we are talking about of salinity. So on an average, salinity varies between 33 to 37. But at places where where less rainfall or where more rainfall, where addition of water, less addition of water, salinity is going to vary. Fine. So this is how the question has been asked in the case of examination regarding salinity part. Clear? So in detail regarding what? Regarding the how the salinity varies in Red Sea, Mediterranean Sea, North Sea. Okay, which oceans, which sea will have more salinity, which sea will have lesser salinity. We'll start that in the tomorrow's class. Fine. Any doubt regarding this one? So remember what we discussed today is what? Concept of oceanic bottom relief. What is bottom relief means? The highland and lowland feature that you are finding which at the bottom of ocean. What are the two type of relief we have discussed? Major and minor. What are major? Shelf, slope, rise, and deep sea plain. And what is a major one? What is a minor one? Trenches, ridges. Fine. Seamount, bouillot. Why these features are being formed? Why these features are being formed? Due to volcanic eruption, erosion, deposition, and tectonic movement, these features are being formed. Fine. And we discuss what is coral bleaching phenomena. When algae get detached from what? Coral polyps. Okay, that refer as a coral bleaching. What is the condition for formation of corals? Mild saline water, shallow water, transparency of water need to be there. Tropical region it is going to be formed. Okay, no acidic water, that is okay there. Mild, mild, mild temperature, not too much extreme temperature. Then in these conditions, coral reefs are going to be formed. We discuss Lakshadweep is which type of island? Coral island. Okay, which type of reefs generally are found in Lakshadweep? No, atoll reef. Reefs are divided into fringing, barrier, and atoll. So which type of reefs generally you see in the case of the Lakshadweep? Atoll kind of reef. Where do we find Great Barrier Reef? Australia. Fine. Thank you for today.